Well, if you've been following along, I've been going through a set of functions and determining their critical numbers, and it's taken me a little bit of time here, but I'm finally going to include some trigonometric functions. And because trigonometric functions are periodic, going forever, we're going to limit finding critical numbers on the interval from 0 to 2 pi, including both ends. Now, as per our usual, let's just make a quick observation. Sine and cosine are always defined. There are going to be no undefined values here, or I should say this is defined for all reals, or at the very least it's defined on this interval. That's what we care about most. So we're going to find the derivative and see what happens with the derivative. But here's another observation. This notation, sine squared, super convenient so long as you know what it really means. Very inconvenient if your brain thinks it knows what it means, but it's wrong. That simply means that the sine function is squared. In order to take the derivative of this, we must use a chain rule. 2 multiplied by sine x, the new power is the first power, excuse me, and then the derivative of sine would be cosine, because that's called the chain rule, plus the derivative of cosine, which is negative sine of x. And if I had been paying attention, I could have just wrote the negative sign here. Let's do a little cleanup. The derivative is 2 sine x cosine x minus sine x. And we ask that same question. Are there any undefined values? And the answer is no. Sine and cosine are defined for all real values. So once again, defined for all reals. I don't need to rewrite that. I'm just making sure it is very clear to everyone that I've investigated it. I don't need to write all reals. I could just say from 0 to 2 pi. I know I've said that, but I want to make sure you hear that I'm processing that information, because you're going to have to learn to process it as well. So, if it's never undefined, I guess the question is, I wonder when it's equal to 0. That's what I want to know. When does that happen? Well, they have a common factor, sine of x. If I factor out the sine, I guess that leaves me minus 1 here. And when you are multiplying and the product is equal to 0, that means either the first factor is 0 or the second factor is 0, since there's only 2 factors here. So now I have to recall on some trigonometric facts, I guess. Well, sine is 0. Remember, we have an interval we must consider here. I don't know if you're the type that uses a circle to determine your values, or if you use some form of a table to think about it. But sine is 0 at these 2 locations on the circle, and that happens when x is 0 or pi, or 2 pi when it's made its way all the way around again. And I have to include 2 pi because I told you to at the beginning. Alright. What about this? Well, if I add the 1 and divide by 2, I get cosine of x is equal to 1/2. And cosine is positive in the first and the fourth quadrants. And if you know your special triangles, you could fairly quickly determine that happens when x is pi over 3, sometimes called 60 degrees. And in the fourth quadrant, that would be called 5 pi over 3. Do not call that value of x negative pi over 3, because this says you don't get to. It has to be from 0 to 2 pi. Wow, 1, 2, 3, 4, 5. Our critical numbers include 0, pi, 2 pi, pi divided by 3, and 5 pi divided by 3. 5 of them. I wonder what that function that we started with even looks like. Well, that's probably for later in this same chapter. There you have it. An interesting looking function with trig functions embedded in it, with 5 critical numbers on the interval that we were provided. There you go. Until next time.